In this video, I want to show you one of my old physics books. This one is called College Technical Physics, and it was written by Weber, White, and Manning. This book is really worn. I feel like various people have used this book over the years to learn physics. I mean, look at that, just all kinds of wear and tear. This is also an unusually heavy book. If I take another book that is the same size as this one is probably going to be heavier. And I think I know why it might be heavier, but I'm not sure. And we'll talk about that in a minute. Here we can see some writing on the inside cover. So there is a name here. It says Joseph E. Otusa, and it's scratched out. So I looked that name up on the internet, and I found out that there is a person who does vision research at the University of Notre Dame, and his name is Joseph E. Otusa. Now, I'm not sure if this was his book. I did try to contact him, but I wasn't able to get a hold of him. In any case, this might have been his book. And if you're curious, Joseph E. Otusa does vision research using mosquitoes. Pretty cool. College Technical Physics. And over here it says, the quality of the materials used in the manufacture of this book is governed by continued post-war shortages. And you can definitely tell that the pages in this book are very different. And I think that's why the book is so heavy. It feels very different, the pages, and they feel pretty good. I wouldn't say they're bad quality. It just has a different feel to it. Yeah, really cool. So this book was written by three authors, Weber, White, and Manning, and they all worked at the Pennsylvania State College. So random fact, Marsh White was the first person ever to earn a doctoral degree from Penn State College. And he was born in 1896 and he died in 1999. Pretty random and pretty interesting, and I'm pretty sure he also did some work for the government during World War II. And this is the first edition. It was published in 1947. According to the internet, this was probably one of the best-selling college physics books ever printed. This is inside the book, and I think this is really cool, especially for a book that was written in 1947. This is the map of physics. Let's go ahead and read this together. It says, containing a brief historical outline of the subject, as will be of interest to physicists, students, and laymen at large, also giving a description of the land of physics, as seen by the daring souls who venture there, and more particularly the location of villages named after pioneer physicists, as found by the many rivers, also the date of founding of each village, as well as the date of its extinction, and finally a collection of various and sundry symbols frequently met on the trip. Here's another look at this map, and I just think it's really cool that they were able to do this in 1947 and put it in a book. There is a lot of incredible detail. I can imagine that this took a ton of work to do and to produce and to put into a textbook. Let's read the beginning of the preface together. This book presents the basic ideas of physics for students of science and engineering at the college level. The topics deemed essential for a first-year course are carefully developed in a conventional order, whereas much material of lesser importance is omitted. The purpose of this book is to help students acquire an exact knowledge of the basic physical principles and the ability to apply these principles with confidence and facility in the solution of technical problems by the scientific method. This is especially interesting here. It says, although algebra and trigonometry are freely used, an attempt has been made to minimize the mathematical difficulties encountered by beginning students. For the benefit of those who need to familiarize themselves with the trig functions of angles, a brief discussion is included in the appendix. The calculus concepts are avoided by use of the increment notation when necessary. So this is a book for college physics. Typically, at least in the US, there's two types of physics courses offered at colleges. You have college physics and you have university physics. College physics tends to omit the calculus, and university physics, or simply physics, includes calculus. This is the table of contents, and I'll just pan through it briefly so you can see all of the contents. I really like how the contents are just very simple. Like there's no subsections, it's just 1 through 31. Here are the rest of the contents. It goes from chapter 32 all the way to chapter 50, and then we have an appendix. One of the really cool things about this book is that it has Nobel Prize winners in each chapter. For example, this is the person who discovered X-rays. His name is Willem Conrad Röntgen, and here he talks about where he was born, and it talks about how he won the 1901 Nobel Prize in Physics for his discovery of X-rays. And these are actually drawings done by an individual. The person who did all of the portrait drawings in this book, her name was Carola Spaeth Hashka, and she made the portrait drawings of the Nobel Prize winners, which appear as chapter headpieces in this book. The portraits are arranged in the order of the dates of the awards. I would say that this book reads fairly well. It reads like most physics books do, and it's really quite nice. I like the size. A lot of the newer physics books are really, really big. I like that this one is just a little bit more compact. And I also love how heavy this version is. It's just such a heavy book. At the end of every chapter, there is a summary of the chapter, which I think is very, very helpful to read after you actually read the chapter. For example, this is the summary on the chapter on meteorology. Meteorology is the study of weather and the atmospheric conditions that contribute to it. Important factors in the weather are barometric pressure, temperature, wind, and humidity. And it just kind of summarizes everything that you read in the section, which really helps reinforce the concepts, I think. Here are some of the exercises in the chapter on vectors, forces at a point. And something that's really peculiar about this book is that it seems that they give you the answers to the even-numbered problems, whereas most modern books give you answers to the odd-numbered problems. So from what I've seen in this book, most of, actually all of the even-numbered problems that I've looked at have the answers. For example, 2 has an answer, 4 has an answer, 6 has an answer, 8 has an answer. And I like how the answer is right next to the problem, so you can try to work it out, and if you have the right answer, you don't have to look in the back of the book. It's right there, it's easy to find, and it's very, very simple. Here's an example on the chapter on rotation of rigid bodies. So you see that they do go through and they show all of the work and work through the solution. So you can learn from this book. And this book, again, was intended for people who do not know calculus. So I think it's a great book for people who want to learn physics. Here's a portrait of Albert Einstein. And again, each chapter has a portrait of one of the Nobel Prize winners, which I think is really cool. This is on the chapter on sound waves. Albert Einstein was born in 1879, and you notice there's no end date. That's because he was still alive when this book was written. This book was written in 1947, and Einstein did not pass away until 1955. Here it talks about where he was born. He was the director of the Kaiser Wilhelm Institute for Physics, Berlin, life member of the Institute for Advanced Study, Princeton, since 1933, awarded the 1921 Nobel Prize for Physics for his attainments in mathematical physics, and especially for his discovery of the law of the photoelectric effect. Albert Einstein is pretty much synonymous with genius. Here's another Nobel Prize winner, and this one was super famous. His name was Erwin Schrödinger, and you'll notice again that he was born in 1887, but because this book was published in 1947, he was actually still alive when this book was published. He did not die until 1961. Here it talks about where he was born, and he succeeded Planck as professor at the University of Berlin, shared the 1933 Nobel Prize for Physics with Dirac for the creation of wave mechanics, theory of interaction of elementary particles. So Dirac, that is the same Dirac from the Dirac delta function. So if you've taken a differential equations class, you might have seen that. Here's an equation that you might have seen before, even if you've never taken physics. 1 over p plus 1 over q equals 1 over f. This is called the thin lens equation. It is possible to find the location and size of an image by algebraic means, as well as by the graphical method already outlined. Analysis shows that the focal length f of a thin lens, the distance p of the object from the lens, and the distance q of the image are related by this equation. Then they go on to derive it. I remember when I was in algebra class and also in physics, I really struggled solving this equation for the variables. You just have to like solve for p. And I remember having a really hard time doing just basic algebra. And here they go through the full derivation geometrically, and then they arrive at the result over here. So it's a really cool book for learning physics. I've had this book for a really long time, and I read it a long time ago, and I'm probably going to pick it up and read it again. I think this is a good book for just learning some physics. You can pick it up, you can read it, and you learn what you learn. There's all kinds of stuff here. Physics is a really deep, rich subject, and it can't hurt to learn some physics. And I think this is a good book to do it with. I found this book online, and I'll leave a link in the description. And as of right now, like even before posting this video, it was very, very inexpensive. There was a few copies available for less than $5. I don't know where I got mine, but I'm pretty sure I probably paid less than $5 for this book long ago. It's a really heavy book, and it's got a lot of history, especially knowing that one of the authors was the first person ever to get a PhD at Penn State, and it's just a nice book. So yeah, I hope you've enjoyed this video. Again, the book is called College Technical Physics. Good luck and take care.